Radar stations A and B are on an east-west line that is 3.7 kilometers apart. Okay, so before I go any further, I'm going to draw this east-west line, and here is A, and here's the east-west line, so this is the point B. So I'm going to draw this dotted line here to represent my north, okay, because this is the east-west line. Okay, let's see. And then this is 3.7 kilometers. Okay, now it says station A detects a plane at point C on a bearing of 61 degrees. Okay, so let's see here. We're at station A and at a bearing of 61 degrees. So let's just put that point somewhere out here. The point C. Okay, there's the airplane. And I'm actually going to connect these. All right, and we know that the north line here is perpendicular to the east-west line here. So this right here is a 90-degree angle, but we'll get with that in a second. This right here is the bearing of 61 degrees. All right, let's continue. Station B simultaneously detects the same plane on a bearing of 331 degrees. Okay, so let's see, let's figure that out. So here is station B. Okay, station B right there. All right, and the bearing there is 331 degrees. So we're going to draw another kind of north line here, and that one is going to look something like this. So this is right here about 331 degrees, let's suppose. All right, so I'm going to put that out here on the outside. Okay, so now what we're going to do, it says find the distance from the point A to the point C. So they're looking for this right here. Well, we know this right here perpendicular, this right here perpendicular. We know if this is 61 degrees, then this must be then, to complete it, 29 degrees. And let's see here. I know that this is 331. Okay, so that makes this sliver right here 29 degrees. And if this is 29, in order to complete the perpendicular there, this must be then 61 degrees. Okay, so this is 29, this is 61. That right there coincidentally adds up to be 90. That means that this angle here must be 90 degrees. Okay, cool. So let's see here. What we have to do is we have to pick one of these angles for reference. All right, so I would say let's go with angle B. All right, and if this is the angle B right here, and let me color it for you in a different pen. This is the angle B. We know that opposite of the 90 is the hypotenuse. Okay, so this is the hypotenuse. It's opposite of the 90-degree angle. But here is angle B, and this is our angle of reference. So we're going to look over here. This is the side we want. This right here is the opposite. So we've got the opposite. We've got the hypotenuse. What should we do? SOHCAHTOA. All right. Well, I'm going to solve for x. Let's give this a variable named x. SOHCAHTOA, the opposite and the hypotenuse. That means we have a case for the sine. So the sine in this case of 61 degrees, all right, the sine of 61 degrees equals the opposite, which we called x, over the hypotenuse, which we're going to call 3.7 kilometers. All right, so we did that. So we're going to now clear the fraction by multiplying both sides by 3.7. And we've got this and this gone. All right, so we've cleared the fraction. And so now all you have to do, again, be sure that your calculator is set into degree mode. 3.7 sine of 61, and you are going to get x equals 3.2 kilometers. Now ask yourself, does this make sense? And actually it does, because if this was the hypotenuse, it has to be the longest side. So we knew from the very beginning that if we were looking for this side of the triangle, it had to have been less than 3.7, in which this case, this is 3.2, so it works out as the answer. Okay, but you can go ahead and verify, maybe doing some different things there. Um, if the question were to ask, okay, now that you know this side and this side, what is the length of this? You could just use Pythagorean theorem, a squared plus b squared equals c squared, and really a manipulation of that to finish solving the rest of this triangle. But a really interesting problem when you're talking about bearings and things like that. So perhaps maybe one day you want to be an air traffic controller or something like that. This is definitely a great application of trigonometry that's involved.